everybody, we're System Error, or the robot, like Vex Robotics Team 21919A. I'm Ava.
I'm Ben. I'm Sedant.
I am Ben.
And this is our second robot of the high stakes 2024-2025 Vex season competition. This robot came from basically a 1 week grind where after our first robot, we disassembled it, changed locations, and assembled a new robot in 1 week of August. And we basically held it, I think, from 9 a.m. to 4 or 5 p.m. for 5 days, and we got a robot. And then we made some more changes later on, but mostly that, and we were able to expand and change our old robot design, and now it works better.
Yeah. So let's start out with the drivetrain.
So for the drivetrain, we have a 4:3 gear ratio, and we have 8 wheels and 6 motors, and you can only see 4 right now because we have them double stacked over here. It's pretty good because it goes fast, but it also allows our driver to maintain control because we have a good driver.
It should be mentioned we use a split arcade drive setup.
Yeah.
That's really helpful.
So so this is the left joystick, this is the right joystick. Left joystick, if you move it up, it goes forward. If you move it back, it goes backwards. And then this one is side to side, so left and right. It's quite smooth, and
this is our second drivetrain. We spent many iterations and just tweaks. We had lots of issues with spacers, and it took really long to align all the gears as well as we could.
And the drivetrain uses 6 motors, but you don't see all of them because some of them are stacked.
okay. Now let's move on to our intake. Menard, do you want to explain?
Sure. So our intake involves 2 stages, the very well and creatively named Stage 1 and creatively named Stage 2. Now, Stage 1, if you'll demonstrate by lifting this, has a pneumatic piston here that we use to collect stacks.
And then
it does a very nice job of collecting stacks. Now, if there were a mobile goal there, it would have easily scored on it. That is a rather conceited thing of me to say, but it is true. So, now moving forward from that, we have a polycarbonate sheet here that we originally intended to mimic the graph of the function y equals e to the x with, but decided not to. However, we still think e to the x is funny, so if you see us in a competition, say it with us, please. E to the x. Now, moving on, we have 2 flex wheels here that we use to allow for easier transition between stages. Trigger again. So, as you can see, there's a slight pause there. These 2 flex wheels make it much easier to load onto the hook. Now, if it wasn't already obvious from what I just said, our scoring system uses a set of hooks, 4 of them on a chain. But not just any chain, we'll turn it around. We also have 2 gears at the back here to allow for these hooks to be at a vertical pointing towards the ground for longer. By doing this, it makes it more efficient at scoring.
Yeah, because it doesn't it helps pull down the and rotate the toruses instead of.
And also, if it just goes straight down, it doesn't have enough time for the full force.
And this took a while for us to figure out, and it would go over, it would go too much, and now it's I dare say it's pretty consistent.
Yes.
Yeah.
Yes.
Now,
the Mogo mech.
Yeah. So as you can see, this is a mogo.
Mobile.
Goal or a stake, as some might say.
Steaks
What we normally do is we drive backwards. We're not gonna drive backwards right now, but we drive backwards, and as we're driving backwards, we attempt to clamp it. There we go.
Now that's a good clamp.
Okay, and then it scores pretty consistently. Yeah. So what's nice about this Mogo clamp is, first of all, it can function at like 25 to 30 psi of air pressure, which is nice. A way we were able to achieve this pretty low air pressure was because we could. It was because normally what people use is they use some sort of a lever that extends and like pulls the clamp in as
like
well.
a slanted one too.
Yes, it's an inefficient third-class lever, to be specific. One that provides a mechanical disadvantage.
Yeah. We originally used this type of like lever, and it functioned pretty badly. It was slanted like this, and it also like couldn't work really well. We had to rubber band it a ton, but here it's just the pistons at work.
Yeah.
Yep.
Also like our previous clamp would require like 60 psi of work, which is like pretty bad, and there was a lot of friction with it. Also, one thing to note is we decided to go for 2 air canisters over 1 because we wanted to make sure that we would not run out of air, and because frankly we could also just do it and it doesn't help, and it doesn't hurt. So the way it works is we pump in air through this socket, and then we chain the 2 together using a couple of right end fittings, and then just pneumatic tubing, and then this goes to the solenoid, which triggers the pistons to clamp, and also for the intake to retract.
And probably for those of you wondering, yes, it is VEX legal, and yeah, we know it's overkill.
Yeah.
Okay, Auton and programming. I'm not the programmer, but one of the parts of our code and Auton is odometry, and for that we have these tensioned wheels at the bottom of the robot at 2 different angles, and they basically help us track the movement of the robot. We also use I think GPS and PID, and we also in the beginning of the seasons, before the season even started, we developed a telemetry code, and by using all of these together we're able to kind of see and track the robot's movement most effectively. So say the GPS is inaccurate, we can take the odometry and compare it. And so I guess the more amount of sources you have, the more accurate you can be. And this helps with our autonomous and just coding, so we can have an accurate Auton. And on the topic of autonomous, we have, I believe, 4 different codes: 1 red wind point, 1 blue wind point, 1 just regular red one, and 1 regular blue one. And the purpose of this is so during qualification matches we can do the wind point ones to up our rank, because autonomous wind points move your rank up, and then in elimination rounds we use the regular ones to score more points, and that helps us in the rounds.
Yeah. One thing to note is for our intake, we originally went for 1 motor, and we just chained it using we used a chain that would link here, and then we would chain it to the first stage. But the problem with that was it was very inefficient. There was a lot of power loss in between it, and the motor would basically would start cutting power at the end of every single match. So we decided to, because we haven't fully developed a claw yet, we just decided to go with 1 11-watt motor for the first stage and another 11-watt motor for the second stage, and that's why it's able to run at a very fast speed while still being consistent in terms of power delivery.
Yeah, it was also pretty bulky up here, and the gears would crash into stuff, and it was not really ideal. Also the I guess the power and energy was lost with the amount of gears that there were, and so here it's like more efficient, and like this motor would like constantly like overheat, and so now it's better.
Yep.
I think that's it with our robot reveal. Thank you
Yep.
for watching.
Like and subscribe.
Yes, shameless shout out. Indeed.
Yeah.
Do it.
And a fun thing, this robot helped us place 5th in the Bay Area first high stakes competition. I forgot what it's called. So
Me too.
yeah. Thanks for
Yeah,
watching.
Thanks for watching. Bye.
Bye.